And that's where some of these kind of gaps come in, which is why I teach, ask for some sort of quality report, so that way you can at least help force them to do their due diligence up front. It's not perfect, but it's a path forward, I think, in the right direction.
Now, here's a hypothetical. Suppose that you didn't notice this, and you said, I need to throw whatever I can at the wall and see what sticks, and get to a design that works within, or at least as close as possible, to spec. How would you do that? Because I bring that up because it seems that it's going to force you to get way over conservative when you have that kind of an incorrect model.
Yeah, that's a good question. And so I actually talk about that in the ECAD paper also, just to prove the point on how important getting that die model correct is, right? And first we go big to small and talk about, okay, what is a die model? And then we go through, what does a die model look like with the package? And we all know, and if you don't know this, but we talk about this Bandini mount, right? Which is really that cue point that occurs between the package and the die model. And it's a function of the inductance between the package and the die. And so I show a simple case study where we put, say, 8 microfarads, of on-package caps, and we have 1 nanofarad of C die. And I hit it with a step load. And you can see I have something like 130 millivolts of ripple, which is quite high. And then what I do is I show the same step load, but instead of 1 nanofarad of, instead of 8 microfarads of on-package capacitance, I go up to something egregious just to prove a point.